Okay, I forgot to do this number 15 together with the previous one, so I apologize for that. Number 15, a baton twirler tosses her spinning baton up into the air. Okay, so some kind of object like this, it gets thrown in the air and it's basically rotating as it goes up, right? Okay, just use your imagination. Okay, while it's in the air, is the baton's momentum constant? What about its angular momentum? Okay, so what is momentum? P equals mv. So is it constant? That means is the delta P equal to 0? Meaning, is the m v final minus v initial equal to 0? Is the delta v equal to 0? No, because as it goes up in the air, it has a certain initial velocity, which is a positive, well, depending, it's a positive scalar, and then over here it's 0. Our v final is 0. So delta v is not 0. So that means that the baton's momentum is not constant. The momentum changes. But now what about the angular momentum? So remember, angular momentum only changes when there is an external torque, right? So an object could have a certain rotation, omega. The only way that the angular momentum changes is if you have some force multiplied by this radius. So there's some external torque that gets applied, right? So when you throw an object, any extended object, and it is rotating as you throw it up, then the only way that that rotating object can change its angular momentum is if there is an external torque. And the external torque requires an external force being applied with a moment arm, a lever arm, about its point of rotation. So if you throw up the baton, you identify its center of mass, its free rotation, right? Remember, free rotation. So you throw it up, it's spinning, okay? It's spinning. But what is the only force that's acting on it? Gravity. And where is the gravity being applied? It's being applied at the center of mass. Okay, that's the center of mass. And under free rotation, what do objects spin about? Which pivot point? They spin about that point, the center of mass. So number one, they spin about the center of mass. Okay, so we know what the point of rotation is, the pivot point. Number two, gravity is applied at that point, which means that the force is passing through the pivot point, the point of rotation, which means that there is no lever arm. If there's no lever arm, then there is no external torque. If there's no external torque, the angular momentum is constant. So number one, the linear momentum is not constant, but so long as the only force that's being applied to that spinning baton is gravity being applied at the center of mass, which is the pivot point, the angular momentum will remain constant.